Alright, so for number 4, we're going to be using the Taylor expansion formula to write out the first few terms of a given function. The first few terms in the power series representation of a given function. So there's two main differences between these and the previous set of problems, which is, first of all of these functions in section 4 of this review are ones that you cannot get by doing any of those transformations we were talking about to the 6 series representations you should know. So for example, here we have tan x, cube root of x, x squared over root 2 plus x, arc sine of x. All of these are things you can't derive from the 6 power series that you should memorize. So that fact in and of itself should tell you you're not going to be able to find a series representation for this because it would be way too difficult. Secondly, these are going to be Taylor series, not Maclaurin series, in that one of them is a Maclaurin series, but these are centered possibly at some value other than 0. So I wrote up here the first 3 terms of the Taylor formula. So remember the Taylor formula, and this works for Maclaurin series too, you just have a equals 0. You take f of a, every subsequent term you take another derivative at a. You start with no x term, and you start increasing the power of x minus a squared, the next one of x minus a cubed. And you start with 0 factorial, which is 1, and you increase 1 factorial, 2 factorial, 3 factorial, on and on and on. So of course, if you were asked for more terms, you would just carry out this pattern even further and write them all down. But all of these problems I only asked for the first 3 terms of the power series. So I wrote out these first 3 terms. We're going to be using this for all of them. So the first one is tangent of x at a equals pi. So we want the first 3 terms in the power series representation of tangent centered around a equals pi. So let's just use the first term. So the first term is simple. We would just do tangent of pi. The second term, so I'm going to write these all out and then we'll evaluate them at the end. So the second term is the derivative of tangent. So recall the derivative of tangent is secant squared. So we would have secant squared of pi times x minus pi. 1 factorial is just 1, so I'm not going to write that there. Okay, and finally the third term, we need the second derivative, so we need the derivative of secant squared, so let's do that real quick. If you have secant squared x, the derivative of that would be 2 secant x times secant x tangent x. So we would get 2 secant squared x tangent x. So when we plug in pi to that, we're going to get 2 secant squared pi tangent of pi. We'd have x minus pi squared, and we're going to divide that by 2 because 2 factorial is 2. So this is the first 3 terms using this formula for f being tangent of x and a being pi. So let's figure out now what all of this stuff is. Well, tangent of pi is 0 because tangent is sine over cosine and sine of pi is 0. So our first term is 0. Secant of pi is the reciprocal of cosine of pi. Cosine of pi is negative 1. So that means secant of pi is also negative 1. And when we square that, we would get positive 1. So this term is 1. And we're multiplying it by x minus pi. And our third term. Again, we actually don't need to figure all this out, because if tangent of pi is 0, there's a 0 stuck in the middle of this whole thing, which turns it into 0. So the first 3 terms of the power series of tangent x centered at pi are just 0, x minus pi, and 0. So in this case, 2 of the terms ended up being 0. It's possible that on a test or quiz you'd be asked to figure out the first few non-zero terms, and you would just have to keep going until you got as many terms as you wanted that weren't zero.